This is the fraction operations quiz number 1 review. I'm going to be going through each of these questions and going over how to get the correct answers to help you better understand this, as well as help you fill out your test corrections to potentially improve your grades. So, question number 1. A carpenter has 2 different boards measuring 80 inches and 64 inches. If the carpenter cuts them into equally sized pieces and has no wood left over, what is the greatest length each piece could be? So I'm going to take the numbers 80 and 64 and find the greatest common factor. Okay, in class you learned the ladder method. Okay, the ladder method is kind of like dividing numbers out. Okay, so I look at 80 and I look at 64 and I try and think of a small number that I could use to multiply to get those two original numbers. Okay, that's in common between both. So I'm like, I think of 8. So I'm going to take an 8 out, which means 8 times 10 is 80, and 8 times 8 is 64. So I draw my next ladder, and I look at those two numbers, 10 and 8, and I'm like, I could take a 2 out of both of them. It works. How many 2's make a 10? 5. How many 2's make an 8? 4. Then I look at my next step ladder and I'm like, there is nothing that I can multiply other than 1 to split up my 4's or 5's. So we're done. So we take our outside numbers and we multiply them to find our greatest common factor. 8 times 2 is 16. The answer to number 1 was A. Number 2. Quincy and Roy were asked to list the common prime factors of 24 and 60 and then determine the greatest common factor. Which student correctly completed the task? At this point, I just want you to find the greatest common factor between these two numbers. And Quincy says the answer is 7. Roy says the answer is 12. So we're going to solve it using the ladder method and see which one of them was correct. So I'm going to write down 24 and 60. And I'm like, what small number could I multiply by to get 24 or 60? It has to work for both of them. I'm going to try 3. 3 times 8 equals 24, and 3 times 20 equals 60. So I draw my next step ladder, and I'm like, what could I divide out by both? And I'm like, 4. How many 4's make an 8? 2. How many 4's make a 20? 5. I look at my next ladder, and I'm like, there's nothing I can take out of these to make them any smaller. So I look at my outside two numbers, I multiply them, and I get 12, which means Roy did this problem correctly. Now we're moving on to number 3, which is dealing with least common multiple. Okay. It says, Georgia listed the numbers below as common multiples of 3's and 4's. Which value did Georgia list by mistake? Well, if you wrote out your 3's and you wrote out your 4's, or you used your multiplication chart, you would know we could do 3 times something to get 12. We cannot do 3 times anything to get 40. We could do 3 times 16 to get 48. We could do 3 times 8 to get 24. So those 3 numbers are going to show up on your 3's list. Now I'm thinking about my 4's. 4 times 3 is 12, so that'll be on the 4's. 4 times 10 is 40. 4 times 6 is 24. And 4 times 12 is 48. My bad, I skipped up. So it says, which value did she list by mistake? Well, the mistake means that this number does not show up in both rows. The answer is 40. 40 does not show up in your 3's row, so it is wrong. Number 4, Mr. Anderson is cutting lumber to use as a border around his garden. One piece of lumber is 8/9 of a foot, while the second piece of lumber is 1/3 of a foot. How much longer is the first piece than the second piece? You should know that we need to subtract this. So my subtraction problem is going to be 8/9 minus 1/3. I cannot solve this right now because my denominators don't match. The bottoms of the fractions have to be the same. So if I looked at my 3's and I looked at my 9's, the first number that would match in both rows is 9. So that means my first fraction is going to stay the same, but I have to multiply my second fraction by something, top and bottom, so that my denominator will become a 9. Well, 3 times 3 is 9. Whatever you do to the bottom, you have to do to the top. So now I need to rewrite my new fractions. 8/9 stays the same, minus 1 times 3 is 3, and 3 times 3 is 9. Now that our denominators match, we just solve it. Subtract the tops. 8 minus 3 is 5, and you keep your common denominator, which is 9. Your answer was 5/9. 5/9 of a foot. Number 5, 2 3/7 minus 1 6/7. The first thing I need to look at are my denominators, and they match. Okay, we've got our least common denominator. Now I'm going to subtract my fractions. I cannot do 3 minus 6. So you have to regroup them. So I cross off my 2 and I make it a 1. When I make it a 1, act like you just took out a whole pizza. The denominator of your fraction tells you how many pieces were in that pizza. So when we took out that whole pizza, we really took out 7 little pieces. And right now they're just floating around looking for their new home, which is going to be up top. Well, there's already 3 pieces there, and we're going to add those 7 in. So 3 plus 7 is 10. Keep our denominator. Minus, keep your second fraction, 1 6/7. Now, our bottoms match. I can do 10 minus 6, so we're good to go. 10 6 minus 6 7, oh, I'm sorry, 10 sevenths minus 6 sevenths is 4 sevenths. 1 minus 1 is 0. So your final answer was 4 sevenths. You have to get an improper fraction here so that it's bigger number minus smaller number. All right, number 6, 7/8 times 5 sevenths. If you multiplied straight across, you would have got 35 over 56, which is a good answer, but it can be simplified. There is a 7 in common between these two numbers. How many 7s make a 35? 5. How many 7s make a 56? 8. Now, if you chose to simplify beforehand, before you solve this, I know that 5 and 8 have nothing in common, looking at that diagonal. So those two numbers have to stay the same. But 7 and 7, they're in common. Well, how many 7s make a 7? 1. How many 7s make a 7? 1. Then you multiply your new tops and your new bottoms. 1 times 5 is 5, and 8 times 1 is 8. Okay, so either option was good. You got the same answer. All right, number 7, 1 7/8 minus 1 1/2. You have to have common denominators. So I look at my 2's, I look at my 8's, and I'm like, the first number that matches is 8. So this first fraction is going to stay the same, but now I have to multiply the second fraction by something so that my new denominator will be 8. 2 times what equals 8? 4. So you multiply it by 4. Whatever you do to the bottom, you do to the top. So now I'm going to rewrite my new fractions. 1 7/8 stays the same, minus 1 1/2 becomes 1 1 times 4 is 4. 2 times 4 is 8. So now I have 1 and 7/8 minus 1 and 4/8. Subtract your fractions. 7 minus 4 is 3. Keep your common denominator. 1 minus 1 is nothing. So your final answer was 3/8. Number 8, 4 and 3/4 plus 1 and 11/12. Same thing. We have to have a common denominator. Okay, our common denominator is going to be 12. So the only fraction we need to change is 3/4. You're going to have to multiply the top and bottom by 3. So 4 and 3/4 becomes 4 and 9/12 plus 1 and 11/12. Add your fractions. 9 plus 11 equals 20. Keep your denominator, which is 12. I can't have this answer. It's an improper fraction. So I'm going to turn this into a mixed number and then add my whole numbers to that answer. How many 12s fit into 20 without going over? 1, which means I just took out 12 little pieces off this top. 20 minus 12 leaves us with 8. We keep our denominator, which is 12. However, they're both even, so I can simplify them. 8 turns into 4, 12 turns into 6. They're still even. 4 becomes 2, 6 becomes 3. So 20/12 is the same thing as 1 and 2/3. But we have to add 4 plus 1, which is 5. So it's 5 plus 1 and 2/3, which is 6 and 2/3. Two problems left. Number 9. Ryan drove 5 1/3 miles to the bank, 6 1/3 miles to the post office, and 4 1/6 miles to the park. What is the total distance Ryan drove? I need to add all of these up, but I can't add them up right now because my denominators don't match. If I look at my 3's and I look at my 6's in my multiplication chart, or I write out my multiples, I know that the first thing that matches is 6. So my new denominator has to be 6. So I have to multiply these two fractions by 2 top and bottom. And this one will stay the same. So I'm going to rewrite my new problems. 5 1/3 turns into 5 2/6 plus 6 2/6 plus 4 1/6. Now that our denominators match, we've rewritten our new fractions. Now I'm going to add my fractions. 2/6 plus 2/6 plus 1/6 equals 5/6. 2 plus 2 plus 1 is 5. Keep your common denominator. Do not change it. Now we add our whole numbers. 5 plus 6 is 11. 11 plus 4 is 15. Okay. This guy Ryan ended up driving 15 5/6 miles for his total day. Last but not least, a rectangular flower garden has a length of 5/8 of a foot and a width of 2.5 feet. What is the area of the flower garden? Area equals length times width. Okay, so we're going to do 2.5 times 5/8. However, you can't multiply when you have a whole number out front. So I'm going to use the MAD method or the C method. I tell my kids it's called the MAD-C method, okay, to turn it into an improper fraction. So we're going to multiply 2 times 2 and get 4, then add our top, which is 5, and that becomes our new top. And you keep your bottom, 2 times 5/8. Multiply straight across, I get 25 over 16. But that's a bad answer. That's a 4th grade answer, an improper fraction. So now I need to figure out how many 16s can we fit into 25 without going over. Well, it's 16 and then 32, and that's too big. So only 1 16 can come out of the top, which is a whole pizza. So I took out 16 little slices off the top. I'm left with 9, and you keep your denominator the same, which is 16. And that is the end.